Again, you're welcome to All I Must TV. Here we have this question before us here. It's a radical equation that has a cube root as radical. How do we solve this question here? The question reads x to the power of 2 minus 2x equal to x into the cube root of x minus 2. What is the value of x here? Here, how do we solve this? I'm going to take you on a smooth journey here. So sit back, relax, even as we dive into this. So let's take our solution here first. So take our solution. Now look at this question carefully. If you look carefully, you'll discover that here we are having x to the power of 2 minus 2x. Look at what we have inside this radical here. We are having x minus 2, right? We can bring out x minus 2 from here if we factor out x from the left hand side of the equation, right? Good. So first of all, let's factor out x from this side. So this is going to give us x into, if we use x to divide this, we're going to have here x minus, we use x to divide this, then we're going to be left with 2. You see? So what we have inside the radical is already on this other side already. So this will now be equal to, here we're going to have x into the cube root of our x minus 2. Yeah. Okay. You can as well put this in bracket. All right. Now, with what we have here now, what we do, never make the mistake of canceling this x out. You can divide through by x, so this will leave the system. But if you do that, you will miss one of the roots, which is 0. If you do that, okay? So for us not to miss the root 0, then we have to leave this 2x here. So move this to this side of the equation. So this is going to give us here our x minus 2 close bracket. If we cross it to this side, it turns to minus our x bracket, the cube root of our x minus 2 close bracket. Okay, now let's watch carefully here. What we do here now, we can now factor x out from this system now. So if we factor x out, we're going to have here x into, here we are left with x minus 2 close bracket minus, here we are left with bracket the cube root of our x minus 2 close bracket. But let's put this in the square bracket. Put this in the square bracket. Everything here equal to 0, this is equal to 0. Okay, now what's the next thing we do? Here we are having a product. This times the whole of this. And here we have 0 on this side. So we result to the 0 product rule, whereby we equate this to 0, we equate this to 0. So let's equate this to 0. So we're going to have our case 1. Our case 1, we take x is equal to 0. So this is the first root I told you of that you're going to miss if you cancel out x from here. So one of the roots to this radical equation is 0. If you put that into the original equation, you discover that to satisfy the original equation. So let's go ahead and take case 2. So let's have our case 2. Case 2 here. What's our case 2? Our case 2, we have our x minus 2. Let's put this in bracket, minus bracket, the cube root of x minus 2, close bracket, equal to 0. Okay, so let's see what will come out of here. So from what we have here now, this is what we do here. Send this guy back to the right-hand side of the equation. So let's do that and see what happens. So we're going to have our x minus 2. This is equal to, here we're going to have the cube root of our x minus 2. Yeah. How do we now eliminate the radical cube root here now? How do we eliminate this? We take the cube of both sides of the equation, right? So from here, let's take this to the power of 3. And at the same time, we take this to the power of 3. This goes with this. So we now have here x minus 2 equal to our x minus 2. Easy. Now, if you check carefully again, here we have power of 3, please. Now, if you check carefully, we can here expand this using the binomial expansion. So we can expand this, right? Good. But if you check what you have in here and in here, they are the same. So instead of expanding this, then just do a simple substitution. So from here, we cannot say let's put u, let u be equal to our x minus 2. So we can rewrite this expression, or this now implies that our u to the power of 3 is equal to u. Move this to this side, so we now have u to the power of 3 minus u equal to 0. Factor out u from this system, so we have u bracket u. Use u to divide this, we're left with u to the power of 2 minus use u to divide this. We have 1 here, this is equal to 0. Remember the zero product rule we made use of the other time? Then we equate this to 0, equate this to 0. So from here, we're going to have our case. Let's take this as a case 2 of star. So case 2 of star, we're going to have our u equal to 0. And what is our u from here? We say let u be equal to this. So if we substitute for our u here, we're going to have here, this now implies that our x minus 2 equal to 0. Move this to this side, so we have x is equal to 2. So this is our s2. Our s2 gives us what? 2. All right. Now we've gotten 2 rules to this challenge here now. Okay, so let's go ahead and look for the other case here, which is this case here now. So let's continue on this side here. Let's manage this space here. Okay, so from here, say here we have our case 2 star star. So we're going to have this to be our u to the power of 2 is equal to 1, because we're going to send this to this other side. So this will now give us 1. Take the square root of both sides. Easy. So take the square root of both sides. Here we add plus minus. This leaves. So we have our u is equal to plus minus 1. So we're going to take the case 1 of this, which is the positive. When we say let u be equal to this, so we're going to have this to be, okay, so this is going to imply that our x minus our 2 is equal to the first one, which is positive 1. Send this to this side of the equation. So we have x is equal to 1 plus 2, which is equal to 3. So we have our x3 is equal to positive 3. All right. So we have this for our x3. Then we can equally use this to get our x4 now. So we consider the negative part of it. So this is going to give us our x minus 2 is equal to minus 1, right? So from here, we're going to have our x is equal to minus 1 there, plus our 2 here, which is equal to what? Our positive 1. Therefore, our s from here is equal to positive 1. So this is our x4. All right. So we have our s4 from here, x3, and here we have our x2. Then here we have our x1. So x1 is equal to 0, x2 is equal to 2, x3 is equal to 3, x4 is equal to 1. All right. So this brings us to the end of this radical equation. However simple it may be, give the video a thumbs up if you learned something from this video. If you have a better way of solving this math challenge here, within split seconds you get your answer, or 4 rules to this challenge, leave it in the comment section so that all Maths TV can equally learn from you. Because we want to learn from the best brains all around the world. Thanks for being there. See you in our next video. Before they keep winning. Bye for now.